for date and time. I'm going to guess it's at the same time, but I don't know what date because we're on the exception schedule because we're not in a block class. Okay, so as soon as I know that, I will let you guys know. Okay, and then the rest of the stuff, that's just what we're going to be doing. So if for some reason you missed class on October 17th, then you know to get class notes from mathematical induction too. Okay? All right, so blah, 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 blah. Sorry. Questions about syllabus, about policy, anything like that I can answer for you guys. Stock syllabus, I mean, it's not like it's anything different than you guys have ever seen in your life, I hope. Okay? You guys sure no questions? Examinations, I let you guys use a note card and calculator, so you don't have to memorize everything, but there's some stuff you'll probably have to memorize regardless, or you'll just do it so many times you'll memorize it. Okay? I'm trying to think if there's anything else about the assessment stuff. I do post the solutions to the homeworks and the exams online, and when I say the solutions, I mean like completely worked out, like every single possible step that you could do, so that way if you get something wrong, you can see what you did wrong before the exam, okay, or on the exam before the final. All right, so other than that, I really can't think of anything else in the syllabus if I have no questions about. No questions, guys? Okay. Let me show you guys Blackboard real quick. I know most of you guys are probably fairly familiar with Blackboard, but if not, okay, I just want to make sure we're all okay with it. Okay. So to get to Blackboard, there's literally 4 or 5 different ways to do it. Okay. Probably the easiest way is just to go to the Harvard homepage, and then if you go under Resources, there's a link for Blackboard under there. Okay. The other way to do it is to literally just type in the Blackboard address. You can go through ALNet if you want to. You can go in Google and type in Blackboard Harvard Community College. So literally 4 ways you guys could do it. Okay. So I'm going to click on Blackboard. To log into Blackboard, all you guys do is use the same stuff as your ALNet. Okay. So let me show you guys. So I'll type in mine. I just changed my password literally yesterday, so now I have to remember it. And it's not found. Well, that's not good. Oh, I did? Yeah. Good thing this is a computer science class and people actually recognize syntax. Thank you, guys. Yeah, all right. Now I forgot my password again. Stupid passwords. All right. So, for those of you guys that have never used Blackboard before, okay, basically Blackboard is going to house a lot of the information if your teacher chooses to use it. Okay, so basically like any documents that your teacher has or any handouts, they might be in Blackboard. Announcements I do through Blackboard. I post, like I say, grades on Blackboard. I post all the assignments, information about the courses on there. So if you ever have a question about anything and you need like a media assistance, you might want to go to Blackboard first. That might be the best place to go. All right, so since we are in discrete structures, let's go to discrete structures. Sounds like a good idea, right? And I'm going to look at the student view, that way. So when you log into Blackboard, the first thing you guys are going to see is you're going to see the course information. So let's say on Wednesday, you forget where the class is, you forget your syllabus, you basically forget everything except your username and password for ALNet. Then all you guys do is just log in, and it's got all the information up there for you. Okay, and then it's got all my information below that. So if you need to get a hold of me, or if you forget my phone number, or you need something like that, it's always in there. Okay, so I would go to Blackboard first just for logistical stuff. Okay, what I would also do is I'd look daily at the announcements. Okay, some of you guys might have already logged into Blackboard, some of you guys may not have. But in Blackboard, I know it's difficult to read, but basically I just posted some stuff about welcome to the course. I'm excited to teach you guys. If you have any questions, contact me, just some basic stuff in there. Okay? So just check through that periodically. What I'll also do is I'll post due dates, and if there's any problems that are very difficult, what I'll do is I'll post a hint under the announcements for that as well. Okay? Because sometimes there are problems, like I make them up, and I didn't realize how difficult they were when I made it up. It happens. Okay? Some of you guys probably ran into that. Like you just get a ridiculous problem that just keeps going and going and going and going and never stops. Okay? So if that happens, you might want to check Blackboard first to see if it's one of those problems. Okay? If it ever does happen that it's just one of those problems that takes like 4 pages, I'll probably just be like, forget it, don't worry about it. Okay? All right, files and documents. Guess what's under there? Surprise, file and documents. All right? If you lose the syllabus, copy of the syllabus is there. All the assignments for the semester are posted. So if you guys want to go under there, and let's say tonight for some reason you just want to do every single assignment that's offered, then you just go in there and do all the assignments. Okay? I won't hand out paper copies of these, so all you guys have to do is just download those and get them. Okay? What else is in here? Exam reviews. So if you basically want to take a look at what an exam looks like, just go to the exam reviews. These are literally just old questions that I pulled off of old examinations. Sometimes in my old age, I just literally put the same questions on an exam review. So it never hurts to look through it to make sure you guys are okay with it. Right. What else do we have? The guided notes. I handed those out to you guys at the very beginning of class. Okay. I'll try to make copies for these, but if you're absent, you might want to go in there and print those out so that way you can copy them from another classmate. Okay? I only have the first 4 up. Okay? I do plan to have the rest of them up sometime soon for you guys, but that's literally like the first month of the course, so you guys should be good with that. Solutions to assignments and examinations. So anytime we have an assignment, what I'll do is I'll post the solutions to that, and that way when you guys get the assignment back, you can just look through to see if you made any errors, what those errors were. I might not specifically mark, or might not write in like a comment as to what you did wrong, but I might circle where you went wrong, and then I might say see solutions, okay? Because obviously there's 25 of you, actually no, 27, sorry, and there's 1 of me, so the ratio gets a little bit difficult for me to write specific notes for everybody, okay? But if it's something I keep seeing from you over and over again, then I'll write like a little note there, okay? So don't get offended if I don't write a note. I just want to make sure you guys know where you went wrong, and then know how to remediate. Okay, and then worksheets. If there's any in-class worksheets that I give out, that's where you go to. Okay, so everything in the course is already posted online for you guys. Email, surprise email. All right, let's say for some reason you're going to miss, like I said, October 17th or whatever, and you just wanted to know if somebody's on campus. You just email all users and just say subject. I'm not a creep. I just want notes. And just type in there, I'm going to be on campus from X time to Y time. Does anybody have class at the same time that I'm free, or can let me copy their notes? Nice and easy. Okay, like I said, there's 27 people. The likelihood that you're going to find somebody in the class that's willing to share notes is pretty high. Okay, so I would recommend that first to being able to go through and do anything else. Okay, I'm not going to email you guys. You probably already get enough junk. All right, grades, surprise, that's going to be your grades. There's nothing posted under there because there are no grades, okay? And then the very last link is textbook. Guess what's under there? Surprise, the course textbook, okay? So like I said, if you didn't want to buy the textbook, I already have a copy of it online for you guys, all right? It's the 4th edition. So the only detriment to this is for those of you guys that like to use like a physical copy of the text. The textbook is 993 pages. So either A, the library is going to kill you, or B, you're going to be killing yourself with paper. So you don't have to print it out. I don't ask you guys, I don't assign anything from the textbook, but I do have it there as a resource for you guys. Okay? If anybody wants to give me money as to what the textbook costs because I posted it online, just leave it up front as you leave. That'd be nice. I'll make sure I buy myself good beer this weekend instead of cheap beer. Okay? All right. So does that make sense, guys, as to why the textbook's optional? It's online. Okay? And most stuff now is online anyway, so I tried to cut down the cost. By the way, how much was the textbook in the bookstore? Anybody know?
$200 just to rent.
$200 to rent, okay? So, or just to get a copy of it for the semester. So, yeah. So, if anybody wants to give me $200 a piece, that would be lovely. So, or even half of that, that'd be great. That'd be like double my salary.
I got it from Amazon for $50.
Oh yeah, yeah. If you get it online, you can get it a lot cheaper. But you know the bookstore, right? Yeah. And now you got that on recording, so now you can just show it to the bookstore and then you can fire me, whatever. Okay, other questions I can answer. Sir, please.
Okay, I look at your syllabus, but you never laid out anything like which are the practice problems for us to do on the book?
If you want some practice problems, I'd be happy to, after class, just circle them for you guys.
Okay.
Or if anybody wants to do the ones that are in there, I'd be happy to just like make up a list for you guys. Quite honestly, in the past, nobody's ever asked me for more work. So that's kind of new to me that somebody wants to do more work, which isn't a bad thing. I appreciate it. But yeah, just let me know if you guys want some extra problems. I can assign them out of the book. It's not a big deal. Okay? All right. Other questions I can answer for you guys. Standard math class. Yeah. Suffering. Yeah. Sorry. Okay. A little bit about me if you care. And if you don't care, that's fine too. Let's see. This is my 13th year at Harvard torturing students. I've taught everything from 1 + 1 up to differential equations. I'm in charge of the honors program. I'm in charge of the honors society. I'm the divisional assessment assistant, some crap like that I got appointed to. So if I don't immediately get back to an email, it's not like I'm avoiding you. Got my computer science degree in 2001, sorry, it hurt to think. Got my master's degree in math in 2006. I don't know. Anything else, just ask. Baseball, beer. That's pretty much it. Okay, so there you go. That's my
No football?
What's that?
No football?
No, you know, I don't mind football, but you know, I play softball on Sundays, so you know, an all-day Sunday. So yeah, sorry, and that's what everyone else does. So not that I don't follow it. I mean, I know I'm current on it, but if you ask me, like, you know, what's a quarterback rating? I mean, I know what a quarterback rating is. I know how to compute it. But if you ask me what Flacco's quarterback rating is based on last year, I'd be like, okay, that's great. So okay. So anything else, guys? We good? Pretty straightforward. All right, cool. All right, so let me load this up, and we'll get started. By the way, if you guys have questions, let me know before you guys forget your question. I forgot what I said 3 minutes ago, so I'm sure if you guys have questions, don't wait until after class, because I bet you there's somebody else with the exact same question. All right, I'll never yell at anybody for saying that's a dumb question or anything like that. I promise, haven't done it. Sorry. There it is. Okay, guys. So, and then let me ask. I know a few guys might have walked in a couple moments late. So, does anybody need the this document that I gave out? Okay. Oh, there might be two in there. No, just one. There you go. You're welcome. Okay. And I'd ask if anybody else needs it, but I'm not going to. So, oh, we go. So, anybody else need one? Oh, there's an extra. Maybe that's why I don't have it anymore. Trade. Thank you, ma'am. Okay. And then, so let's go ahead and start filling out some of these definitions so that way we can start working on some of these problems involving logical forms and logical equivalents. Okay. So the first part of the course, we're just going to go through logic, definitions, logical connectors. So there's going to be very little arithmetic. Okay, but there's going to be a lot of like critical thinking that goes on. Okay. So any time we talk about, and I'm going to just write up here because that thing's not calibrated well. Anytime we talk about a statement, okay, a statement is basically a sentence that's either true or false, but not both. It could be either quantitative or qualitative, okay? Like for instance, a statement, a very simple statement could be, my name is Chris, okay? Another very simple statement could be, I'm a millionaire, okay? Doesn't matter if it's true, doesn't matter if it's false, it just matters that it's either true or false. In other words, it's not an opinion, okay? Like for instance, you guys could say, the best color on earth is red. That's not a statement, okay? So again, statement is something that's true or false, but not both, okay? A statement with its only one idea is a simple statement, okay? So I'm just going to number these. So anytime we have a simple statement, that's basically what I just said, okay? So if I say, my name's Chris, I'm a millionaire, okay, my name is Chris, period. That's one simple statement. I'm a millionaire, that's another simple statement, okay? If it has two or more statements and it's connected by a logical connector, that's going to be called a compound statement, just like a compound sentence. For instance, a compound statement could be, my name is Chris, and I am a millionaire. Okay, that's a compound statement. Okay, or I could say, my name is Chris, or I'm a millionaire, something like that. But it has two different ideas to it, just like a compound sentence would have. All right. Sometimes there's going to be statements that are always true. Sometimes there's going to be statements that are always false. Okay, a statement that's always true is called a tautology. And again, that's logically, okay? It doesn't matter necessarily in real life, okay? Like, as far as I know, my name is Chris is going to be a tautology, okay? I'm not planning to change my name anytime, unless for some reason I get busted by the IRS and I have to flee to Mexico. All right, then I'd have to change it. Okay. A statement that's always false is a contradiction, okay? For instance, I make a lot of money. That's a contradiction. I will never make a lot of money because I'm a teacher. Okay? So these are all, I guess, the basic sort of ideas that we're going to go through, okay, or I guess the most essential stuff that we need. And I'm going to guess some of you guys have heard this stuff before, some of you guys have never heard it. It's easy stuff. It's not that big of a deal. Okay. Now I want to talk about these logical connectors. Okay. When we have have these logical connectors. In mathematics, instead of using the word and, we use the upside down V or the caret. Okay? If you see this symbol, or, it's like a V, it's going to be, it's basically the same thing as an or, which is going to be a V. Not, some of you guys in computer science, like I think for C or C++, use the exclamation point. We use the tilde, okay, that's called the negation. And then a conditional statement, if then, is just going to be an arrow. Okay, we're going to see how to write these things in a few moments, but I just want to make sure when you guys see these, you know what they mean. Okay, so basically, for those of you guys that are programmers, you start out with your basic syntax. This is the most basic syntax of mathematical logic. Okay, so this is where we start with this stuff. Okay, in mathematics, whenever you have two simple statements joined by an and, that's called a conjunction. Okay, if it's connected by an or, it's a disjunction. If it's not, it's a negation. And then, like we said before, a conditional statement is an if-then. Okay. Generally, I'm going to use this terminology. Okay, so if you hear those words, make sure you know when I say conjunction, I mean an and. Disjunction or, negation not, and then conditional if-then. Okay. All right. So just a few more of these, and then we can go ahead and start working on some examples of when we would use this stuff. Okay. So when we talk about a statement form, okay, a statement form is an expression made up of statements and logical connectors. Okay, so now we're basically saying, okay, if I have a compound statement and it starts having some logical connectors in it, that's when it starts becoming a statement form. Okay. So now we're starting to be able to define some simple statements, to be able to write them using the mathematical lexicons up there. Okay. In a conditional statement, the antecedent is the statement that logically precedes others. Okay. So if I talk about an antecedent, that means that's going to be the first part of a conditional statement. Okay. And then the second part is going to be the conclusion. So there's an antecedent and then there's a conclusion for this. Okay? Sometimes the conclusion is called the predicate as well. Okay? So let me in parentheses. Almost like an English sentence. Okay? You always have like your noun part and then your verb part.
I'm typically used to writing predicate.
Mm-hmm.
Would it be okay if I use, it's the same representation of it, but just a different one?
Perfectly fine. Okay. Yep. I don't really care which one of those you use. If I put it up there. Okay, good question. Thank you. Okay. Yeah, if you guys are used to something else, just ask me beforehand. Like for example, like the tilde. Like if you've been programmed for 16 years of your life to use exclamation point, just use exclamation point. Just ask me first. Or define what it is, so that way I know that you know what it is. Okay, that's all. Okay. So any questions I can answer for you guys about these definitions? I mean, it's basically it is what it is stuff. Okay. So I want to start by taking a look at how we're going to start writing some of these statement forms. Okay. So the first set of examples that we have up here. Okay, I want to write the following statements using defined variables and symbols. Okay, so these are really easy problems. It's just kind of getting our feet wet with these statement forms. Okay, so for letter A, the sky is blue and the grass is green. Okay, again, it doesn't matter if it's true, doesn't matter if it's false. Here's how I would write this symbolically. Okay, I have two simple statements going on here. So what I'm going to do is I'm going to define P is one simple statement, and Q is another simple statement, just like you guys would do with a string in computer science. Okay? So, if I was to ask you guys to define P, okay, what would be one of the simple statements that exists in this sentence?
The sky is blue.
The sky is blue. Okay, so for P, we would write the sky is blue. Not blue. Sorry, spelling doesn't count. And then for Q, what would be the other simple statement?
The grass is green.
The grass is green. Okay, so the sky is blue, the grass is green. Okay. Without those definitions, if you just wrote the answer without defining those, it means nothing. Okay, it's just like if you guys tried to execute a computer program and you didn't define like P as an integer, as P as a floating point or something like that, wouldn't matter. Your program would crash. Okay. So if I want to write this using our syntax, The sky is blue and the grass is green. What I would say is P and Q, okay? And the answer is actually all of this stuff. Okay, so you have to define your variables first, and then you have to write the statement, okay? And don't forget, guys, like we said before, logical connector, this guy means and, okay? So we're just going to be seeing these over and over. By the time we're done with this section, you'll probably remember what's an and, what's an or, etc. Okay, easy enough, right, guys? If this was 5 points on your first examination, you'd all get 5. Okay, another question. Sean is not tall, or Kathy is Canadian. Okay, so once again, we have 2 different statements. Okay, there's a couple ways that we can define this. Okay, so what's one way that you guys might define the first statement?
Sean is tall, then not signed before?
Yeah, we could do Sean is tall, or we could do Sean is not tall, right, guys? If we do Sean is tall, then we have to put the negation of that when we go to do it, okay? And then obviously the other one is Kathy is Canadian. Canadian. So if we had those definitions, then what we would say is not P, and since it's an or, we have the upside down caret or just a V, and then Q. Okay, so like I said before, guys, without the definitions of P and Q, if you just put that last statement there, not P or Q, unfortunately that wouldn't be correct. Okay, you have to define P and you have to define Q if you want full credit. Okay? All right. So any questions, guys, I can answer about that one? Pretty straightforward. Okay, yes, sir.
Why is P not, Sean is not tall?
It could be, okay? So it just depends on how you define it, okay? So, sir, if, let's say for some reason you defined it as P is equal to Sean is not tall, and then you said Q is equal to the same thing as it was before, then you would just say P or Q. And if you did that, that's perfectly fine, okay? And so it doesn't really matter which way you define it. I'm okay with either way. So both of these would be perfectly acceptable. Just like if you guys were writing a computer program, maybe you just said you don't want something to happen. Okay, you could define it a couple ways. So does that make sense, sir? Okay, you could do it either way and you'd be fine. Okay. All right, other questions, guys, I can answer? Okay, for the last one, a letter C. If I am rich, then I'm not a teacher or I am a politician. Okay, so I think in this one, there's probably going to be 3 simple statements, aren't there, guys? The first one is I am rich, not if I am rich. So let's let P be equal to I am rich. Okay? Because remember, a statement is something that's either true or false, but not both. If it says if I am rich, I don't know, what does that mean? That's not even a complete statement. Okay? Define Q to be either I am not a teacher or I am a teacher. Let's just say I am a teacher. And then finally for R, we can define R to be I am a politician. Not saying this is the only way to do it, just saying that this is one way to do it. You could have defined Q to be I am not a teacher. Okay? So if I was to ask one of you guys to write this in symbols as opposed to writing it as in the sentence form, does somebody think they can use what I have up there to write it? Go ahead, sir, please.
P conditional, and then negation, Q, disjunction, R.
Nice. It doesn't matter if you have parentheses in this one, okay? But generally, it might be helpful to put parentheses after that, just so it's grouped together. Although, like I said, in this problem, it's okay to do it without the parentheses, okay? Because the order of operations, okay? Sir?
It almost seems a little bit unclear if it doesn't have parentheses to me, though, because that end sentence kind of is
Right.
one.
The order of operations says that you do negation first, then you do disjunction or conjunction, then you do the implies or the conditional. Okay, so that's so for this problem it would work, but for other problems it might not. Okay, my suggestion is, guys, use parentheses regardless, just to make it easier for you. Okay, and we haven't gone through the order of operations yet, so you guys wouldn't know anyway. Okay, all right. So questions I can answer for you guys about before we go on and we start talking about truth values and compound statements and that sort of stuff. Okay, really easy stuff to start out with, right, guys? But all we're doing is we're just defining these so that we can move on and start talking about more difficult stuff. Okay. So some more fill-in-the-blank stuff. So when we talk about a truth value is going to be the value assigned to some sort of statement. Okay, so let's just start over again. We'll just start at 1. So this is a truth value. Okay? So truth value is going to be the value that's placed on some sort of statement. Okay? There's only 2 truth values, either true or false. There's no opinion, there's no maybe, there's no I'll do that next week. Okay? It's either true or false, or if you want to use 1 or 0. Okay. And for those of you guys that are computer minded, you like 1s and 0s better because that's binary. Okay. So whichever one you want to use, I don't care. Okay, I can figure them both out. Okay. For it to be true. Okay, so let's go back to the table that we had earlier, and let's kind of think about these guys right here, these logical connectors. Okay. So which of those 4, if I go back here, which of those 4 do you guys think has to be true? If I had 2 statements together, which of those has to be both true for the entire statement to be true?
And.
Yeah, the and statement, right, guys? Or in other words, the conjunction. Okay? So, for a conjunction to be true, both of the simple statements must be true. Okay? Like if I told you guys, okay, I have a blue marker and I have a black marker. They both have to be true for me not to be lying. If I say something like, I have a blue marker and I have a magic baton that when I zap you, you're going to get 50,000 volts through your body. Okay? One of those is a lie. Okay? Thank God. All right? So that would not be a true statement. Okay? So, if I wanted to say, and I'll scroll back down. Okay? For a blank to be true, either statement or both statements must be true. So which one is that, guys? The disjunction, right? An or statement. So next to conjunction, I'll put and. Disjunction. For a disjunction to be true, only one of the statements at minimum has to be true. They both could be true. Okay? Like for instance, if I said I have black marker or I have magic wand that's going to zap 50,000 volts through your body. Okay? I'm not lying to you because I have one of the 2. Okay? A lot of times it's just dependent upon what we want to utilize. We're going to see that later in the course. Okay? So for conjunction, both of the statements must be true. For disjunction, at minimum 1. They both could be true. Okay? And then finally, for a blank to be true, then the statement must be false. So that would be which of the 4 that's left over, or which of the 2 that's left over. Negation, right? For a negation to be true, the original must be false. Okay, so I think one of the most basic sorts of instruments that we can utilize in logic is a truth table. Okay, truth table is very foundational. Okay, it's almost like add, subtract, multiply, and divide when we talk about arithmetic and algebra. Okay, and even calculus. You have to know those things before you can do anything more, and that's the same thing with a truth table. Okay, so basically a truth table is going to be all the possible permutations that can come out from n statements in a compound in a statement form. Okay, could be simple, could be compound, could be a whole bunch of them. Okay, if there are n simple statements, there are 2 to the n rows in the truth table. Okay, so for instance, our second example, we have 2 simple statements. That means there would be 2 squared or 4 rows. If I was to construct a truth table for our third example, there are 1, 2, 3 simple statements, which means there are how many rows, guys?
8.
8 rows, because it would be 2 to the third. Okay? So one of the things you guys might want to do is before you even start doing the truth table, think to yourself, how many rows are there going to be? Basically, however many different letters there are, that's how many rows there's going to be. Okay, that's as easy as it gets. I'll show you guys an ordering for this. All right. I want you to notice that on the notes that we have, okay? One of the first things I want to make sure of is that if I give you guys a simple disjunction or conjunction or some sort of conditional or negation, that you guys are able to figure out the truth values for those. And I think we've already done that, but we can fill these in, okay? So let's say we're talking about the conjunction. Guys, what did we say has to be true for a conjunction to be true?
Both have to be true.
Both of the statements must be true. So, for P and Q to be true, a true and a true, real nice, gives an output of true as well. Okay, sorry, this isn't lined up well. Okay? The other three of those are going to be false. As soon as you see a false in a conjunction, the rest of it's false. Okay, so let's get the better as I do now. It's not quite done. Okay? So the first one's true. Sorry about that. I know it's not good, but we'll just blame it on the line. The line for this thing. That's no better, is it? Okay. So let's talk about a disjunction. Okay. What did we say has to be true for a disjunction to be true? At least one, right? Or even both, right? So if I was to ask you guys to fill out the truth values for this, okay, what would be the 4 truth values for a disjunction?
True, 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 false.
True, 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 false. Right, guys? Okay. So this would be true. This would be true. This would be true, and this would be false. Okay. So for a disjunction, only one has to be true. Okay? All right. Now for implies. Okay, this is the one that tricks a lot of students. Okay? The way that I think, or let me ask this first. Maybe somebody knows already because they've seen it before. Does anybody think they might know what the truth values are for a conditional statement? Go ahead, sir.
Is it? Because the tricky ones is the false. False implies true. That's the tricky one. So it's true, true.
True, false, true, true. No,
Is it
true,
false, true, true.
It is true, false, true, true. Okay? That's okay. I'll explain why. True, false, true. Okay. That's the only one that's sneaky. Okay? Yeah, and then you're probably like, okay, I can't remember like in my head like which one. That's okay, no big deal. Think of this statement, okay? If I study, you don't have to write this down. I'm just justifying this. Then I pass. Okay? If I tell everybody in this class, if you study and do what you're supposed to do, then you will pass. Okay? That's my promise to you. Okay? Let's think about this. Let's say you study and then you pass. Do you get what you deserved? Absolutely, right? I promised if you study, you will pass. What if you study, in other words, this first part's true, but the conclusion is false? Have I held up my end of the bargain?
no.
I have not. So that's why, if you study, you do not pass is false. Okay? Now, think about this. What if you don't study, but you do pass? Did I lie to you guys?
No.
No. Okay? I mean, you still passed the course without doing anything. Okay?
But
So
you
I
did.
didn't lie to you. What if you didn't study and you didn't pass?
That's true.
That's true, right? I told you, if you study, you'll pass. If you don't study, you're not going to pass. So if you're ever on like an examination or sitting there for your homework, okay, I always tell students, think back to this statement. If I study, then I pass. And just think about, if I promise that to you, what happens if you do or don't do what you're supposed to do? Okay, so does that make sense as to why it's arranged like that? Okay, and some of you guys might have never seen this before, but it is what it is. Sort of. Okay, and then the last one's our negation. So the negation's easy, right, guys? If the original statement's true, what's the negation? False. And if the original statement's false, the negation is true. Okay. These you guys should at some point memorize. And when I say at some point, I'd say as soon as possible. Okay, so these are ones that you guys are going to be fundamental to us being able to do the rest of the problems. All right, questions I can answer before we go on and actually construct truth tables from more difficult statements. Okay, so this is more likely as to what you guys are going to see like on a quiz or I'm sorry, on your homework and on your examinations. Okay, to where I give you guys some sort of statement form. And I want you guys to write some sort of truth table for that. Okay? Some of you guys have done this before, some of you guys haven't. So if I'm moving slow with this, I'm not trying to insult your intelligence. I just want to make sure you guys are okay with this. Okay? So I'm just going to do it on the board, but obviously you guys can do it in your notes packet. All right. I look at this statement. How many unique simple statements do we have in this statement form, guys?
2.
Not 2, but
Or
3, right? We have P,
Q,
Q,
and R.
The not P doesn't count, okay? So that's probably the one you were thinking of, right, sir? Yeah. Not P is just a negation of it. So there are 3 statements, which means how many rows are we going to have?
8.
8. So we have 3 statements, which implies 2 to the 3rd rows, which should be 8. Okay? So, like I said, even before you start the problem, it might be viable for you to think, how many rows are we going to have? Okay? All right, we have 3 simple statements. We have a P, we have a Q, and then we have an R. Okay. I don't know if this is helpful. Okay, this is the way I always arrange it because I think to myself, okay, there's got to be 8 rows. Okay, so the way I think about it is the first 4 of the P's should be true. The second 4 of the P's false. And by the way, this is an algorithm to where you guys get all of the different permutations for this. Okay? So the first 4 true, second 4 false. Then instead of going in groups of 4, we go in groups of 2, right? So I'm going to do true, true, and then false, false, and then true, true, and then false, false. What should I do to get all the permutations with the column R?
True, false, true, false.
Yeah, just keep alternating, right? Because if you think about it, doesn't this go in 2 squared? So that's how many trues I should have in a row. Doesn't this go 2 to the first, which tells me how many trues I should have in a row? And this would be 2 to the 0, okay? So basically, guys, if you ever had, let's say for some reason you go into like you have like some crazy guy that wants you to do like, I don't know, 5 variables, which would be 32 rows, then what you would do is you would do 16 trues, 16 falses, and then 8 trues, 8 falses, 8 trues, 8 falses. So you just keep going in descending powers of 2.
So 2 to the power n minus 1, that's how you do it?
That's exactly right. And n minus 1 being the previous number of trues in a row. Okay? So this would be true, false, true, false, true, false, true, false. And I'm just doing this. And I'm trying to use the different colors just to indicate when you guys should be changing. Okay? So does that make sense, guys, as to how to set up the table? It's a really easy way. That way you guys don't have to think too much, that you've got all the different permutations in there. Okay. So let's think order of operations here. Okay? If you're just in a regular math class, guys, what has the highest precedence?
Parentheses.
Parentheses, right? So let's just do what's in the parentheses first. Notice that I have P and Q in the first parentheses. Okay, so that's what I'm going to do. My next column, and you don't have to do it this way, but if you've never seen a truth table before, you might want to start by what's in the parentheses, okay, just like a regular order of operations. Okay? Guys, what did we say has to be true for a conjunction to be true?
Both have to be true.
Both P and Q have to be true, right? So what are the only 2 rows that are going to have an output of true?
First one.
First one.
And second one.
And the second one as well, right, guys? Because if you look at the first row, don't we have P and Q? So that's a true. And then P and Q are both true. So that's true. Do we care what R is, guys? No, we don't care what R is. There's no R in that statement. So why are we even caring about R for the next one? Okay, so these are true, and then the rest of them have at least 1 false. So the rest of these animals are falses. So does that make sense, guys, as to why we did P and Q first, because it's in the parentheses? And then secondly, does it make sense as to how we got that column? Any questions? Okay. Next thing we do. There's still another thing in the parentheses, right, guys? There's a not P or R. Okay, so that's the next thing we're going to look at. So not P or R. Now this is a disjunction, which means that what has to be true? One of those 2 has to be true, right? So basically, couldn't we just look at the R and say wherever R is true, that's got to be true no matter what? Okay, so let's do that first. So it doesn't matter which one is true. So first of all, we know that R is true here. We know that R is true here. We know that R is true here. And we know that R is true in row 7. Well, should be row 7, not 6.5. Sorry. And, boy, that's not even close. Sorry about that, guys. Okay. So does that make sense, guys, as to why we can fill those in immediately? I just looked at R, didn't care about the other thing. Now, what else should be true for us to put a true in that last column that we have so far? P should be false, right, guys? Because if P is false, so P should be false. Or let's say P can be false. Because we're taking the negation of P. Okay? So remember, it's either one of those that has to be true. Okay? So since P is false here, or I'm sorry, P is true, but not P would be false, that means that this is false. Since P is true here, and R is true here, that means that this guy is going to be false as well. Okay? So this just says false here, false here. Since this guy is false, we want to take the opposite or negation of false, so this guy would be true. And then finally for the last one, since this P is false, the negation says that it must be true. Okay? So basically, if you've done this correctly, everything should be true except rows 2 and 4. Okay? Does that make sense as to why that is, guys? Any questions? Okay, good. All right, I'm almost done. Okay, I've done what's in parentheses. Now I just have to go through and do the disjunction that's in between those, right? So right now, guys, the first 3 columns don't mean anything. The only thing that matters to us is the very last column, which is P and Q, or not P or R. So notice, guys, how we're working with this. We're working from the inside of parentheses, and we just keep growing this statement. Okay? So just like a regular order of operations problem. All right, we said that for a disjunction to be true, either of those statements must be true. So let's just take a look at the first line. Okay? What would be the output on the first line of this,
True.
guys? True, right? Because these are both true. So this is true. For true, false, what's the output for the last column if it's a true, false?
True.
True as well. In fact, doesn't it look like that every row is going to be true except for which row, guys?
4.
Row number 4, right? Because it's the only one where they're both false. So this is almost a tautology. So I don't know what you would call that, an altology. Meaning it's almost a tautology, but I don't know. It's like you guys are driving like in a 1-lane road, like if you're ever riding down 22 and you're in the 50-mile-per-hour zone and some jackass is going like 35 miles per hour and you're just completely screaming because you want to choke them out. So maybe I shouldn't say that on the first day of class, but regardless. Okay. Does this make sense, guys? Any questions, okay? You work from the inside of parentheses and then you just keep growing your statement form until you get to the end of it, okay? It's not too difficult, but it's all predicated on those 4 tables that we looked at before. Okay, so here's what I want you guys to do, okay? I want you guys to go ahead and see if you guys can take about 5 minutes, see if you guys can do letter B, okay? You should have maybe 3 columns for this. You can probably get away with 2 columns and make it work, okay? So do the exact same setup to begin with and then grow your statement out, okay? If you guys need some help, raise your hand. That's what I'm here for, okay? Sir, please.
What's the 2 and the squared and the 2 and the...
Oh, that's how many T's you should have in succession for that column, okay? So notice how we start out with 2 to the 3rd. The first column should have 2 squared trues in a row. The next one should have 2 to the 1st, and then 2 to the 0. So just in descending order. So that way, like if for some reason you had like 4 or 5 rows, that would make it work. Does that make sense, sir? Okay, good.
Yeah.
Sure. It's just an easy way to make it. Okay? And if you know a different way, I don't have any problem with that. This is exactly what you guys are going to see for homework. Question like this will probably be on your exam. Okay, so not trying to trick you guys, just trying to make sure you guys understand it. That's all. financial trouble or psychological trouble, I highly suggest you go somewhere else. Give you guys another minute to finish up, and then we'll go through the answer to this. For those of you guys that are done, how many of you guys use 3 columns? How many of you guys use 2? Make it work. That's fine. Anybody use 1?
I wrote 3 columns just to figure out in my head how 2 columns would work, and then I realized, oh, okay.
Yeah.
Like I wrote it, but I didn't use it.
Okay. How many of you guys use 0 columns? That's good. Just can't do it. Okay, so somebody tell me, what was their first column that they constructed? What might be like the most logical place to start?
The not P, or Q, R.
Yeah, I would start with the P or R, or not P or R. Good, Don. So, now Don, you did P or R, correct? Or not P or R?
I did not. P
Okay,
or R.
sir, do you mind if I just start off with that? Because not everyone's seen it before, but that's perfectly fine. So you could either do P or R, because it's in parentheses, or if you're pretty good with the stuff, you could have done not. Now remember, what has to be true about P or R to be true?
Either one.
One of them, right? So for the first row, in fact, for the first 4 of these, wouldn't the first 4 be true? Because they're all true. So no matter what, the first 4 of these are going to be true. And then, what about row number 5? Because the P is false, but the R is true, that's going to be what? True. Good. In row 6, both P and R are false. We don't care about Q for this first part, so false or false gives us a false. False or true gives us a true. False or false gives us a false. Okay, so if you did P or R as the first column, everything should be true except for lines 6 and 8. Okay, does that make sense to everybody, guys? Okay. Now, if you were to go through, the next column you could have done, or the first column you could have done, was not P or R. Okay? So maybe some of you guys are good at this and you've done it several times. So you said, okay, well, I just know what P or R is going to be, so I just take the negation of that. So can somebody tell me what column P or R not should look like?
All should be false except 6 and 8.
That's absolutely correct. Very good, sir. So opposite of true is false. Opposite of true is false. Opposite of true is false. Surprise, opposite of true is false. False. And then finally, when we get down to row 6, we get a true, we get a false in row 7, and then a true in row 8. Okay? So does that make sense, guys? And Donnie, that's what you got out of that, sir?
I actually got 1 and 3 false.
Oh no! Well, don't ever do that again.
Okay.
Okay. All right. So, but you understand why it wasn't. Okay, that's fine. Yeah. And remember, guys, this is the first time some of you guys have seen it. So if it's not clicking, don't get scared. Okay? It's just one of those things where it just might take some of you guys a little bit longer. You might have to come and see me to get some help for this. Okay. The third column, which could be the last column or the second column, however you did it, not P or R implies Q. So the only columns that we care about to get that last column are going to be those 2 columns, okay? So notice that we already know what not P or R looks like, and we already know what Q looks like. Now, remember guys, for a conditional statement to be true, there's 3 ways, and there's only one way for it to be false. What is the only way for a conditional statement to be false?
The first
part to be true and the second part to be false.
Correct. So basically, if this column has a false in it, the output has to be true no matter what, right guys? Because false implies true, false implies false are both true. So I know that if it starts with a false, since false implies whatever is true, I'm going to get true, 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 true. I'm going to hold off on this guy because I don't know yet. And I know row 7 is going to be true as well. Okay? So the way I think about conditional statements is, as soon as I see a false as the first input, in other words, the antecedent, I just put a true there. Okay? I don't mess around with it. Now, let's take a look. For the second, or for row number 6, I have true implies true. Okay? So notice I have true implies true. Guys, what do we know about true imply true?
True.
That's true. Okay, so that's good. And then once again, I think we get an altology because I notice that we have a true implies false, and we can't have that. Okay? So unfortunately, since we have true implies false, it's almost a tautology, but not quite. Okay. So this is what your truth table would look like. Okay. And some of you guys might be thinking, well, where would I ever use this stuff? Okay, like why in life do I even have to go through this garbage? Okay. How many of you guys like to play around with circuits and like try to build breadboards and things like that? Well, this is exactly what you guys would do. You'd buy some logical connectors, you'd hook it up to a breadboard, and you would get it to have some output. Okay. I remember when I was in college back in the 90s. Yeah, so seriously, back in the 1990s, not 1890s. But one of the first things that we ever did was we actually had a breadboard. We linked it up to a basic program. And what was really cool is that we got the breadboard to talk to the computer by using just basic circuits like ands, ors, or nots. Okay? So I'm sure they have much more sophisticated things nowadays, but it was one of the coolest things I remember doing in school, besides smoking pot, so whichever it was. Okay? So guys, I just want to make sure that you guys know that this stuff is used in real life somewhere. Okay? And it's not just stuff that I'm torturing you guys with, although it's the same thing with most math. It's applicable somewhere to somebody, but maybe not. Okay. So, one of the last things we're going to look at this afternoon is we're going to say, what if I want to know if two statements are logically equivalent? There's actually two ways. Oh, sorry.
Quick thing. Why is the final truth table not under the implies symbol, but under the or symbol?
Let me answer your question. Say your question one more time. Why is the last column?
Yeah, why isn't there? Why aren't we doing it over like the main symbol that's sort of...
Oh, I see. We did it with respect to the order of operations. So order says you do what's in the parentheses first,
Right.
then you do a not, then you go through and do the implies. Implies is always
okay.
last.
Okay, so that just wasn't done yet.
Correct.
Oh,
right.
okay.
Yeah, that's
Okay.
all. So we were just basically building up to it to be able to get that. Does that make sense now, sir?
Because I did that. I think I kind of like.
That's okay, but you're good now.
Yeah, I get
Cool.
it. I get it.
Okay, that's all right. All right, other questions, guys? Okay, so one way that we can show that two statements are equivalent is being able to use a truth table, okay? Because if we take two statements and they have the exact same truth tables, that means they must be logically equivalent, okay? So, basically, two statement forms are logically equivalent. And by the way, when you see IFF, that doesn't mean I spelled it wrong. But does anybody know what IFF means in mathematics?
If then thens, right?
Not if then else,
It's testing equivalency.
which means you're right.
It's a two-way, right?
It's not biconditional, but
If and only
if
And
and
only,
only if.
yeah.
Okay. So whenever you guys see this, okay, this might be helpful because we're going to be using this quite often. If you see IFF, that means if and only if. So if some of you guys ever have, if you got some of you guys who might be math majors and you have to take like abstract math or abstract algebra, they use that all the time. Okay, so I just want to make sure you guys are good with that. So I want to prove or disprove the following using a truth table. Okay, so we have P and Q or R is, when we see triple equal means logically equivalent. Okay, so when you guys see this guy, again, it's just that I wasn't drunk and made up one more line than I should have. This just means logically equivalent. So logically equal. Yeah, as if my handwriting isn't bad enough. And I put it on the smart board, it looks even worse. Okay. At the end of the course, we're going to look at geometric equivalencies like isomorphisms. It's the same thing, like logical equivalence. All right. Guys, if I want to show that these two statements are logically equivalent, which they are, I can use a truth table. Okay, so that's what I'm going to do. All right. So what I'm going to do first is, I have my truth table over here. I just erased everything. It still has 3 lines, or I'm sorry, it still has 3 variables, which means we're going to have 8 rows in this. I'm going to build a truth table for the left side, then I'm going to build a truth table for the right side. Okay? So what I'm going to do is that this is going to be LHS, or the left-hand side. Okay? And then I'm going to have something for the right-hand side. All right. If I'm looking at the statement form, I notice that I have P and Q in the parentheses. So like we said, guys, always start in parentheses. You can't go wrong if you start there. Okay? Didn't we already say that for that to be true, both P and Q must simultaneously be true? So just like before, isn't it true that only rows number 1 and 2 are true, and then the rest of them are false? So this is going to be true, true, and a bunch of falses. Okay. My next column, if I'm looking at the left-hand side, should just be P or Q, or sorry, P and Q or R. Okay? So this is going to be P and Q or R. The first 2 rows have to be true, okay? Because we already know that P and Q is true in that first row, and it's P and Q, which is true, or something else. Okay? So we already know that these 2 are true. And then for the rest of them, that's when we look at R. Okay? We don't care what P and Q is anymore, because we know that the rest of them are false. So now what I'm going to do is I'm going to look at R, and I'm going to say, okay, well, R is true in row 3, in row 5, and in row 7. So true, true, true. And then I just put falses in the other 3 spaces. Okay, so false, false, false. All right, so this is our left-hand side equivalence. Okay, so does that make sense to everybody, guys? All I did was basically the same problem we just did for the last 20 minutes, except I just looked at the left-hand side. Okay, so now, if we're looking for equivalence, what we have to make sure is that it's equal logically to the right-hand side. So now what I'm going to do is I'm going to build the right-hand side, and if they are the same, they're logically equivalent. If they're not the same, that means they're not logically equivalent. Okay, so for our right-hand side, again, we start in the parentheses, so I have a P or R. And then I also have a Q or R, I believe. And then the last thing I'm looking at is I'm looking at P or R and Q or R. Okay. So before I go on, I just want to make sure everyone's okay with why I'm setting it up this way. Okay? Does everybody understand that the reason I'm setting it up is because I want the left-hand side and the right-hand side, and I want to compare those 2. Because if they're the same, that means that these are logically equivalent. So I'm just building it just like we did in the other 2 problems. I'm going parentheses, and then I'm doing like the connector between those.
So the last column is the right-hand side column?
That's correct. This guy right here is the right-hand side. And essentially what we're hoping is that these 2 are the exact same. Okay? If those 2 are the same, that means that the statements are indeed logically equivalent. Okay? So now it's just up to us to be able to fill that in. Okay? So P or R. Well, remember, guys, either one of these can be true. So I know the first 4 are going to be true. And I know that when R is true, so that would be rows number 5 and 7. And then the other ones are false. Okay. So like I said, guys, the sooner you guys memorize those 4 initial tables, the easier it's going to be for you guys to fill out the rest of it. Okay. For Q or R, okay, so now what I'm doing is I'm just looking at these 2, And remember, Q or R means that one of the two has to be true. So it looks like row 1 is good, row 2 is good, row 3 is good, row 4 is not good, 5, 6, 7 is good, and then row 8. So basically everything except for row 4 and row 8 are going to be good. So we have true, 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 false, true, 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 false. All right. Last thing we have to do is we have to look at the last two columns that we have there, and then hopefully those last two columns, when we do the and between them, because what you'll notice is it's P or R and Q or R. So now all I'm doing is I'm just taking these last two rows and I'm just kind of melding them together and seeing for the and. Okay, so can somebody just go down the list and tell me what the last column should look like with the truth values for those? Go ahead, sir.
True, 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 false, true, false, true.
True, 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 false. True, false, true, false.
Yeah.
Okay, thank you, sir. That looks good to me. So, true, 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 false. Okay, and remember, for this to be correct, both of those must be true. Okay, so, true, true, true. And then as soon as you see a false, that output is false. Okay? Same thing, true. So row 5, row 6 is false, row 7 is true, and row 8 is false as well. Alright, now we actually need to answer the question. And the question is, are these logically equivalent? Well, I take a look at this column. I take a look at this column. Okay. And I want you to notice that row 1, 2, and 3 are true, row 4 is false, row 5 is true, row 6 and 8 are false, and row 7 is true. So they have the exact same logical outputs, which means that it is a true statement. Okay, so this is valid by truth table. Okay. What we actually did was I gave you guys this handout that we didn't use today. Okay, but I want you to notice under the basic logical equivalencies, okay, that this is actually one of the distributive laws. Okay, so if you go down to distributive law and you take a look at this, I guess it's going to be the second one where we have P or Q or R. I know the letters are a little bit mashed up, or not matched up necessarily, but it's exactly what we did was we actually proved the distributive law in this. Okay, and the most fundamental way to prove these logical equivalencies is to be able to use a truth table. Okay, so that's why we're actually looking at these, so we can prove these. And next time we're going to be able to use these to be able to prove more difficult statements. Okay, so next time what we'll do is we'll do that last problem that we have. Then we're going to start looking at the Boolean algebra stuff, which a lot of students don't like too much. Then we're going to start taking a look at maybe some of these argument forms as opposed to statement forms. Okay, sir?
Generally speaking, for the sake of this class, will we be only working with these statements?
Yes, I will not, as long as you guys don't piss me off, I will never give you more than 3 statements, which I don't necessarily see that. Okay, plus that means, bless you, that's twice as much I do anyway. Bless you again. Okay, so other questions I can answer. Okay, so assignment 1, you guys should be able to do like maybe the first half of that assignment. Generally what I do is I go through 2 classes and then an assignment's due. So I'm guessing assignment number 1 is going to be due not next Monday, but next Wednesday, because next Monday we're not going to be on campus, right? So I'll post this in Blackboard for you guys, but there's nothing due next time, but you might want to work ahead of it.
Is this assignment 1 the one we are doing?
No, sir. Assignment's posted on Blackboard, okay? But that is the material that you need to be able to do.
Okay.
All right, go ahead.
The assignment submitted online, or we print out paper?
You just print out a paper copy and then you just give me the paper copy in separate pages, okay? All right, guys, if there's something you guys need from me besides money or psychological help pulling up, and I'll try to help you out with that, okay? If not, then I'll see you all on Wednesday.